This is the Thomson Reservoir, the largest water storage ever constructed for Melbourne's water supply, and one of the most important elements of the city's modern water supply strategy. It was built not just to meet demand, but to help Melbourne withstand drought and future-proof its entire system. But how did this colossal project come to be? By the early 1970s, Melbourne's population had passed 2.5 million, and water demand was still surging. A comprehensive network of reservoirs, Sylvan, Upper Yarra, Greenvale, and Cardinia were already in operation. But planners and engineers knew that it wouldn't be enough. Climate variability, population growth, and the scars of past droughts made it clear. The city needed something bigger, more remote, and more secure. After extensive hydrological studies and catchment analysis, one location emerged as the standout: the Thomson River in Gippsland. With its high, consistent rainfall, sparse development, and steep terrain, it offered ideal conditions for a large-scale storage scheme. Thus began the staged development of the Thomson project, a long-term vision that would take nearly 15 years to complete. The first part of the development came online in 1974, with the construction of Thomson Stage 1, the Eastern Weir, a small diversion structure that tested downstream capacity and water rerouting. It was followed in 1977 by Stage 2, the Swinglers Weir, built below the Jordan River to further expand flow regulation options. At the same time, infrastructure was being built downstream to receive and treat water from the future dam. In 1981, the Sugarloaf Reservoir and Winnicky Water Treatment Plant were completed at Christmas Hills, enabling treatment and distribution to northern suburbs. This work established critical elements of the delivery system well before the dam itself was completed. The decision to construct Sugarloaf and Winnicky was driven by more than just future-proofing for Thomson. It reflected a new way of thinking about Melbourne's water management. Strategically located in Christmas Hills, the site was chosen to serve a dual purpose: storing diverted water from Maroondah Reservoir and the Birrarung, and treating it on-site for direct supply to the city's northern and northwestern suburbs. Like some of the other storages in Melbourne's network, Sugarloaf is a 96 gigalitre off-stream reservoir, meaning that it doesn't rely on catchment runoff like Upper Yarra, Maroondah or Thomson. Instead, water is pumped directly from the Birrarung at Urang Gorge and also diverted from the Maroondah Reservoir via the aqueduct. So the two water sources can be utilised at once. This setup gives operators flexibility, especially during variable flow periods, allowing for dynamic balancing of water levels across the broader network. The Winnicky Water Treatment Plant was a major step forward for water quality assurance. Before Winnicky, most of Melbourne's water came untreated from its closed catchments and was of such high quality that only some chlorination was needed prior to distribution to service reservoirs and customers. Winnicky introduced full conventional treatment: coagulation, flocculation, sedimentation, filtration, and disinfection, aligned with public health standards. It was the Melbourne Metropolitan Board of Works' first modern, large-scale treatment plant. Designed to handle roughly 300 megalitres a day, Winnicky supported both local supply and system-wide delivery through Sugarloaf's connection to the water grid. It has undergone several upgrades since opening, with improvements to automation, filtration, and operational resilience. Together, Sugarloaf and Winnicky became a crucial node in Melbourne's ever-evolving water network, offering a combination of storage, treatment, and supply flexibility that supports the entire metro area. Their creation marked a shift in Melbourne's water story, from a system built solely around pristine catchments to one embracing modern treatment, decentralised storage, and integrated planning. Construction of the main Thomson Dam, Stage 3, began in the early 1980s. Engineers designed a massive rockfill embankment dam with a clay core, standing over 165 metres high and extending more than 500 metres across the valley floor. Behind it, the Thomson Reservoir would eventually hold up to 1,070 gigalitres, making it the largest reservoir in Melbourne's water supply system. To be clear, Thomson isn't the largest reservoir in Victoria. That title goes to Lake Dartmouth in the state's northeast. It holds roughly 3,800 gigalitres, followed closely by Lake Eildon, which has roughly 3,300 gigalitres. But neither of these two reservoirs play a role in Melbourne's drinking supply network. Thomson, by contrast, is Melbourne's primary drought reserve, intended to secure the city's future through prolonged dry periods. The dam wall was completed and the diversion tunnel closed in May 1983, but it would take until 1988 for the system to become fully operational. During this period, monitoring equipment was calibrated and the dam was allowed to settle and fill gradually. Key to its operational function supplying Melbourne's water network was the Bells Portal outlet and tunnel, which permits transfers of water from the Thomson storage into the Upper Yarra Dam. From there, it flows into Sylvan and then on to Melbourne. Similarly, given that the reservoir impounded the Thomson, which supplies the irrigation networks of the Gippsland region, the dam itself had an outlet tower arrangement, and not long after, it was fitted with a mini hydro generator, providing a useful revenue source for the Board of Works. Unlike other storages in Melbourne's network, Thomson was designed for long-term strategic use. It's not drawn on daily. Instead, it's held in reserve to be tapped when other sources are running low. This buffer role allows for the rest of the system to operate with more stability and flexibility. That strategy proved critical during the Millennium Drought. From the late 1990s through to the mid-2000s, Melbourne experienced its driest conditions on record. Reservoir levels across the system dropped to historical lows. It was the Thomson Reservoir that bore much of this burden. Its massive capacity used strategically to maintain flows, meet urban demand, and prevent overall system failure. But even the Thomson couldn't make up for years of minimal inflows. At one point during the drought, Melbourne's overall water storages fell below 30%, triggering major water restrictions, emergency planning, and widespread concern over when the drought would finally break. Around this time, authorities considered expanding the Thomson catchment by diverting the Ep4 River, a major tributary in the adjacent valley. This catchment had originally been earmarked for diversion under Stage 3 of Thomson's development. The idea, however, was shelved, largely due to environmental concerns and the growing recognition that new dams alone wouldn't be enough. Another scheme, known as the Warrandyte Storage Project, also failed to materialise in its full form. It proposed building 2 additional reservoirs to Sugarloaf, the Watsons and Yarra Brae storages, also situated in the Yarra Valley. But yield projections proved inadequate, and these plans were dropped. I'll try to explore that project further, pending time and viewer interest. The millennial drought exposed Melbourne's vulnerability to rainfall-dependent systems. In response, engineers and planners pivoted towards diversified supply strategies. Desalination, recycled water, stormwater harvesting, and demand reduction would all play a role in the future of the network. Yet even today, the Thomson remains Melbourne's most significant reserve. It is actively monitored using real-time telemetry, rainfall forecasts, and inflow projections. Its management is now integrated into the broader system planning, balancing efficiency with resilience. It remains a cornerstone of water security, not just as a source, but as a symbol of foresight, engineering, and long-term planning. In our next episode, we turn our focus to the millennial drought itself, how it reshaped public thinking, political decision-making, and the future of water planning in Melbourne. I'm Paul Mike Lengus. Thank you for joining me.